This is Chapter 9, Lesson 2. And last lesson we looked at using Pascal's triangle for finding out the numbers we're going to use for the binomial expansion. Now, the first objective said we're going to use it for n being very small. Now, if we asked for to do a question, say, to the power of 30, we certainly don't want to extend this 30 rows, so that'll take a long time to do. So there is a shortcut. And we can actually use the combinatorics button on the calculator. So on your calculator, you're looking for this button here. Now, for a particular row, the number that starts with 4, then the first number is 4C0, 4C1, 4C2, 4C3, 4C4, and so on. So you might want to try 4C0, make sure you get 1, 4C1, you get 4, 4C2, you get 6, and so on. And if you want to experiment on a different row, if you want to figure out what a particular number is, say like this one here, so the key number here is 6. So 6C0, 1, 2, 6C2. Now notice also some of these are going to be the same because of the properties of Pascal's triangle with it reading the same forwards as backwards. So 6C4 should also equal 6C2. And significantly 2 plus 4 is 6. So if I told you that the value of 7C2, then you can figure out that it's also the same as 7C5. Using that property. So last lesson we looked at finding coefficients, so something like this. So power of 4, so we looked at this row here with the 4, x to the 4, x to the 3, x squared, so we'd use this number here. And substitute in the numbers, 5 to the power of 2, because 2 plus 2 is 4, which is the power in the question. Evaluating all this gives us 150. Now we're going to do the same idea, but from now on, and rather than doing this method, we're going to try and use the combinatorics method. Now we don't have the 14th row of Pascal's triangle, so this question would be very difficult anyway. But we do know the first few numbers in Pascal's triangle. We certainly know that it starts with 1. The next number would be 14, obviously, for this question. But then that third number we wouldn't be very sure. So we're going to have to start using our new method. So the numbers from Pascal's triangle come from 14C0, 14C1, 14C2. And as we already said, this is going to be 1, this is going to be 14, and you can work that one out on your calculator. And you should find that it turns out to be 91. Now everything else we should be able to do the same as we did in the previous lesson. So x to the power of 14, x to the power of 13, x to the power of 12, just decreases the powers. And the other way around for the second term, so 3 to the power of 0, 3 to the power of 1, and 3 to the power of 2. And once again, notice these two powers in each case add up to 14, which it is in the original question. Then we can start to evaluate all these, and I actually have this already calculated, so let me get rid of this, and then we can see. And just check that you agree with that answer. Let's try a slightly more complicated one. So what is the coefficient of x to the 5 in 1 minus 3x to the 9? We're trying not to use Pascal's triangle if we can help it. So we know that it's going to go 9C0, 9C1, 9C2, etc. So if we're doing the second term here, which is x to the 0, we'd actually start x to the 0, x to the 1, x to the 2, x to the 3, x to the 4, x to the 5. So we're going to use 9C5 for this question. Notice when we did the questions last lesson, normally it said like 2x plus 1. So as we were counting, we counted down with the x's. With it being the second term this time, we're actually starting with 0 and counting up. A very common place where people do make mistakes on this question. So the number from Pascal's triangle, 9C5, which you can work out on the calculator, is 126. Negative 3 to the power of 5, 1 to the power of 4. Noticing the two powers add up to 9. And then we can figure out what the answer is. So ignore the x to the 5. It's just going to be simply that number. Question's a little off the top of the screen now. What is the coefficient of x cubed in 2x minus 5 to the power of 8? So this time the x term is first, so we're going to count downwards. So x to the 8, 7, 6, 5, 4, 3. So we're going to use 8C5, or we could just have used 8C3 as well, making sure it's the same power as the x there. So number from Pascal's triangle, we need this term to be cubed, to give us our x cubed. The other term, 2 powers have to add up to 8, so we're going to make that a power of 5. And then we can work out each of these terms. And we do end up with some very large values for this. So don't be surprised if we do have values that go into the millions, as you can see in this example. That should be enough for you to actually answer the first few questions now from exercise 8b. So we've got what looks more like an ACE question here. First part should be fairly simple to do, but this second part's certainly new. So, oops, I'm going to reveal all that so you can see what's happening here. So there's my numbers from Pascal's triangle. This is 10c2, because the other ones you should better work out. Power of 10, first number's obviously 1, second number's the same as the power, so 10, and then this will be 10c2. First term, decrease in powers, power of 10, then 9, then 8. Second term, negative 3x, increase in powers, 0, 1, 2. You can see the 2 powers add up to 10 as well. And using your calculator, you should be able to find out, oops, that line, that those are your first 3 terms. Now, the part that we have to work out is this 1.97 to the power of 10. Seems pretty random, so look at the original question to see how it relates. Well, this is also to the power of 10. So what we need to know then is, if this sequence, or the first 3 terms of this, then when does 2 minus 3x to the power of 10 equal 1.97 to the power of 10? So first of all, if they have the same exponents, the bases must be the same. So I can get rid of that. And then if I solve this for x, what I find out is that x turns to be 0.01. Now, for most of the questions you're going to do, x is either going to be 0.1, 0.01, or 0.001. And so what we're going to do is, rather than substituting that into here, or if we're actually working this out, we're going to take this value and plug it into here, and then that will give us what we're actually looking for. Now, if we just substitute directly into there, we just get 1.97 to the power of 10. So we're going to use our answer that we got from that, the first 3 terms, so in other words, this. And we're going to plug that into here. And this is the part we can almost do without a calculator. So where it says x, 0.01, and the same on this last term here, where it says x, 0.01 squared. Then we can work out what this is. So when we times by 0.01, that's the same as moving the decimal point back 2 places. This is supposed to say minus here as well. And if we times by 0.01 squared, that's the same as moving the decimal point back 4 places. Now the reason we only need to do the first 3 terms, look what's happening here with this pattern. We start off with something in the thousands, we then got something in the hundreds, we then got something in the tens, and this converges very quickly. If we were to do 4 terms, it'd probably just be a difference of 1, and if we did 5 terms, it might even be a number less than 1. So these first 3 terms should give us a pretty good approximation. Now we just got to work out what that actually gives us. And on my calculator, I got 880.768. Now, just as a comparison, just to actually check, if I do 1.97 to the power of 10, then what I actually get is, the correct answer is 880.364, 3 decimal places. So pretty close actually. We got 880, we got 0.7, the correct answer was 0.3. And considering we only worked out 3 terms of what's actually 11 terms, a pretty good approximation to what the real answer actually was. Now I'm going to show you the second type of ACE question that they like to ask, but I'm going to use the original first question so we don't need to rework that. So we found the first few terms, hence find the coefficient of x squared in this expression. Now notice that this was part of the original question, we're just going to times it by 3x plus 1. Now I left my original answer here. So what we're doing is 3x plus 1 times by this. Now we could just go ahead and multiply this out. There's only 6 terms. But most of these terms aren't actually going to help us find x squared. So if I do x times x, then that will certainly give me x squared. So that's one part of my answer. If I do 1 times a number, then that will also give me part of my answer. So 3 times negative 15,360 is negative 46,080x. 1 times 103,000 is obviously going to be 103,680 x squared. And then if I combine those two, then that'll actually tell me how many x squared I have. So that equals 57600 x squared. And as it just says, find the coefficient. Let's get rid of the x squared term. And that's going to be your answer. So often they'll also like you to find part of the sequence and then times it by this. And if they don't specify, normally first 3 terms is a pretty good starter for those questions. So you can figure out what the coefficient in the second part of the question is.